Thank you all for joining. I welcome you all to this webinar. We have some exciting topics to cover. I am Kahre, a product manager at SolisFAST, and joining me is my colleague Hanna Sein, also product manager. Today's talk will be focused on lyophilization and different related topics and what SolisFAST can offer to make this a success. If you have any questions, feel free to ask them in the chat, and we will try to answer some if we have time at the end. And yeah, before we dive into today's topic, I will take a few moments to briefly introduce SolisFAST for those who are not familiar with us. SolisFAST is a biotechnology company located in Estonia with nearly 30 years of experience in the biotechnology sector. We develop and manufacture high-quality molecular biology reagents with a focus on reagents meant for PCR and related technologies. We have partners and clients all over the world in a wide variety of sectors, from molecular diagnostics to basic research, who have come to love our catalog products and our many custom solutions. So what makes SolisFAST unique? Well, at the core of SolisFAST are our enzymes, and at the core of our enzymes lies our unique and patented technology called the stability tag. The stability tag is a special polypeptide sequence that stabilizes the enzyme structure and enhances significantly its resistance to temperatures, meaning that in liquid form, our enzymes and master mixes are stable at room temperature for a minimum of 1 month and up to 6 months for certain master mixes. Interestingly, the inclusion of stability tag does not impair enzyme function or protein function, and we have tested it on a variety of different enzymes, not just polymerases, but also nucleases, reverse transcriptases, and proteins such as ribonuclease inhibitors, LIF, and different growth factors. This technology enables us to offer simplified handling and logistics to our clients and offer reaction setup without any ice. Additionally, it allows us to ship our products in an environmentally friendly manner without the use of any dry ice or ice packs. The reagents are shipped either in cardboard boxes or simple padded envelopes all over the world, reducing styrofoam waste and enabling convenient and unique uses for our enzymes. As mentioned before, we have successfully implemented the stability tag technology in many proteins, and that includes all of our catalog products and custom solutions, either as standalone enzymes or master mixes that are stable in liquid form for a minimum of 1 month. Continued innovation and strong expertise in protein engineering has allowed us to stay competitive and offer a wide variety of enzymes, master mixes, kits, and other custom solutions that have been very well received by the market. Without going into too many details, you can see here on the slide a brief overview of the different product groups and enzymes that we have available at SolisFAST. As today's talk is focused on lyophilization, you might be wondering, why is lyophilization even necessary when the enzymes are stable? Well, there are direct benefits that lyophilization can offer that liquid solutions, such as our master mixes using stability tag technology, don't quite provide, as the buffer composition also plays a critical role, making sure that the mixture is stable, and adding components such as primers and probes to offer a ready-to-use test kit is not always possible. However, the stability tag can still help withstand the demanding lyophilization process by providing the necessary robustness to the enzyme. And without going into too much detail about this lyophilization process, I think this is a great place for me to hand it over to Hanna, who can expand on this and talk about lyophilization in more detail.
Thank you, Oliver, for this nice introduction to SolisFAST and to the stability tag technology. I am Hanna Sein. I'm a product manager at SolisFAST, and today I'm happy to talk about lyophilization and what we have to offer for this technology. So before going deeper into the benefits of lyophilization and what kind of solutions we have to offer, let's just quickly go over the general concept of this technology. So lyophilization is also called freeze drying. And in a nutshell, this is a process of water removal. And it increases product stability and also, very importantly, preserves product functionality. So my colleague Oliver has already told you about the stability tag technology and what kind of a benefit it gives to our liquid reagents. And it's true that the liquid reagents have a remarkable high stability at higher temperatures. But simply a PCR reagent is not enough to perform target-specific detection. And for that purpose, primers and sometimes also probes are needed as well. So any kind of modification to a liquid reagent can have a negative effect on the stability of the reagent. So what if there is a wish to mix together different components, commonly the PCR reagents and primers and probes, or if there's a wish to modify the reagent composition by the addition of other chemical compounds? This is exactly where lyophilization is a good solution. Lyophilization improves the stability of complex solutions at higher temperatures. So this can be a more complex PCR reagent, and this can also be a full PCR assay where the reagent and the primers and probes are mixed together. Thanks to the stability tag technology, we can already ship our liquid reagents without any ice worldwide. But now, thanks to lyophilization, we can also talk about shipment of full assays without any dry ice. And by reducing dry ice usage, we also reduce carbon footprint. And by making the packages lighter and smaller and dry ice free, we also can reduce shipping costs. Since the stability of the products is improved, the products also have a longer shelf life in their lyophilized format. And there's a reduced need for continuous refrigeration. When we look at lyophilization from the point of view of an end user, then we can definitely talk about simplified workflows. So if the end user, let it be a lab specialist, someone working at a clinical laboratory, for example, if they receive the reactions in a pre-mixed all-in-one reaction unit already, then there's less pipetting left for the specialist to do. Most of the work, most of the preparation work has already been done for them. And this, of course, maximizes user convenience. The only thing left to do is to dissolve the lyophilizate through a process called reconstitution. If there's less steps to do, there's also a reduced risk of making mistakes, and therefore there's also a higher consistency in results. We definitely see that there is a concrete market segment that probably benefits from the lyophilization technology the most, and this is the point of care testing market. In order to take testing to the point of care, ice-free shipment can definitely ease up the process, and it's therefore also possible to take testing to remote places. And since reconstitution is basically the only thing left to do in order to perform the reaction, then we can also talk about using untrained personnel to perform testing, and we can even talk about self-testing. And later on in today's webinar, my colleague Oliver will also talk about another technology beside PCR, which is also very beneficial for the point of care testing markets, and where we now also have exciting solutions to offer. So stay tuned for a lot of interesting information to come. But now, when we look at all these benefits, we can say that we surely understand why lyophilization is such a growing trend, and we're also happy to now play along. When we look at the lyophilization process itself, then we see that it's a rather complex process. It consists of different stages, and the conditions during the process are quite harsh. The temperatures range from around -50 degrees to around +25 degrees. The pressure changes from atmospheric to very low pressures. And it's very important to keep in mind that the reagents really need to withstand all this stress, and they need to remain functional after going through this entire process. So not all reagents are suitable for lyophilization. And what kind of requirements are there for the reagents? First of the requirements is a glycerol-free composition. And there is a bit of like a conflict there because glycerol is mostly used as a stabilizing agent when we talk about liquid reagents. But when these glycerol-containing reagents are taken to lyophilization, then since glycerol is such a thick and viscose fluid, it can really complicate the lyophilization process, and the lyophilizates can be sticky at the end. So a glycerol-free composition enables efficient freeze drying to produce stable lyophilizates. And the second main requirement is the inclusion of lyophilization excipients. And as mentioned before, the lyophilization process is quite harsh, and the excipients serve as cryoprotectants, meaning that they protect the reagents from stress during this procedure. And they also take care that the products remain functional afterwards. And additionally, they provide an adequate structure to the lyophilizate. So now that we have talked about the technology of lyophilization, we know the benefits, and we also know a bit of the process and the requirements for the products in order to be suitable for lyophilization. We can now also talk about one of the main characters of this webinar, which is the product SolisFAST Lyo-Ready qPCR kit with UNG. In a nutshell, this is a fast and sensitive qPCR solution for probe-based assays. The format of this product is a two-component kit, and in one tube we supply a glycerol-free qPCR mix, and in another tube we supply an optimized excipient mix. And when these components are mixed together, the product is suitable for lyophilization into lyo cakes and lyo beads. The product is also suitable for 5-plex amplification and is compatible with fast cycling protocols to reduce runtimes, and it also contains UNG to prevent carryover contamination and false positive results. Since we supply all the components necessary for lyophilization, this product can be used as a Lyo-Ready solution. But the two-tube format also gives this extra flexibility, and it's possible to work with your own choice of excipients should that be necessary for your lyophilization procedures. Now, in order to convey information about the quality of the products in a universal way, certain temperatures are used, and these are called critical temperatures. First of them is TC, or the collapse temperature of the frozen state. Here we are hoping for the highest possible temperature because the higher it is, the higher can also be the temperature that's being used in the primary drying phase of the lyophilization protocol, meaning that less energy has to be spent in order to cool down the freeze dryer, and there's also increased consistency between lyophilization runs and lyophilization batches. The second temperature is TG, or the class transition temperature of the dried state. And also here, we are hoping for the highest possible temperature because this is a good indicator for the suitable storage temperature at which the lyophilizates can be stored at for long term. And a simplified formula tells us that the suitable temperature for long-term storage is at Tg minus 50. When we now take a look at the table below, then we see that our critical temperatures are quite competitive when we look at the temperatures of other Lyo-Ready products from other suppliers. When we now also add to this table the information from our ongoing set of stability tests, where we currently see that the lyophilized products are stable for at least 6 months at plus 25 degrees, which is actually higher than the recommended Tg minus 50. And when we also consider a very low residual moisture percentage of 1.4, we can confidently say that the kit enables the production of highly stabilized lyophilizates that are resistant to long-term exposure to higher temperatures. Of course, one of the most important parts of lyophilized products is that the functionality of the product needs to remain the same before and after lyophilization. So here we have performed a set of tests to show exactly that. So we have tested the product in its liquid form, in its lyophilized form, and also in its lyophilized form together with a 5-plex primer and probe set. This means that we have lyophilized a full assay. And here, this set of data clearly shows that the kit ensures consistent performance with persistent CQ values before and after lyophilization, as well as after lyophilization with primers and probes. Since the product contains the SolisFAST DNA polymerase, which has very fast extension rates, we also wanted to see how does this product perform with different cycling protocols. So we have tested 2 different protocols. One is more of a standard protocol and other one is slightly faster. And we have tested these protocols with both liquid reagents and also lyophilized reagents. And the message in this table is actually quite simple. Within 1 DNA dilution, the CQ values obtained with all tested conditions are very consistent. There's minimal fluctuations in CQ values, and we can confidently say that the product produces consistent CQ values before and after lyophilization with both standard and fast cycling. To sum up, this glycerol-free liquid reagent, SolisFAST Lyo-Ready qPCR kit with UNG, offers the possibility to lyophilize this product into Lyo beads and Lyo cakes. And the product is strongly protected during freeze drying, thanks to the supplied excipient mix. And the lyophilizates have a high resistance against long-term exposure to higher temperatures. And the reconstitution process is rapid and seamless and can be done with simply water or a DNA sample. And the qPCR performance is preserved after lyophilization. Additionally, the product also contains the UNG enzyme, which takes care of eliminating carryover contamination and preventing false positive results. And the product is also compatible with quick cycling protocols. So this is where I would like to hand it over to my colleague Oliver to also tell you a little bit about other solutions that we now have available in our product catalog that can also be used for lyophilization. So go ahead, Oliver.
Thank you, Hanna, for this interesting talk on lyophilization and explaining what it can offer and what are some of the requirements and challenges associated with it. Parallel to lyophilization, Another growing trend in the diagnostic sector is point-of-care testing, which is also commonly achieved with the help of lyophilization, as Hanna already briefly touched upon, to really improve the portability and stability of these assays. We see more and more the need and desire to administer tests either at home, as we were all quite familiar with during the COVID-19 pandemic, or near the site where the patient is located, providing results in a rapid and efficient manner instead of waiting for days for laboratory results. So there is an increasing demand in the market for simple, portable, and accurate diagnostic tests, as well as the development of portable handheld devices. However, certain methods, such as antigen-based tests, might not have the fully desired reliability and accuracy. One such technology that enables similar precision and sensitivity as PCR is isothermal amplification, where instead of the usual cycling of temperatures you see in PCR, the reaction is done at a constant temperature. So maybe more specifically, rising popularity is loop-mediated isothermal amplification technology that can offer a lot of these benefits, such as being relatively simple, portable, and also accurate. PCR is often held as the golden standard of diagnostics. However, it is limited by the need for specialized equipment, like a thermocycler, and trained personnel to actually carry out the tests and analysis. As mentioned before, LAMP or loop-mediated isothermal technology, isothermal amplification, is one such technology that has shown great promise for use in point-of-care testing devices. It can be used for rapid diagnosis in low-resource settings, in remote or mobile healthcare settings, as the reaction is done at a constant temperature and can be performed by a simple heating block or a water bath. Additionally, as the reaction itself and the readout are relatively simple, there is no real need for specifically trained personnel to do the analysis or the setup. And that's where the benefits of LAMP are most apparent, in situations in which a relatively unskilled individual can do the entire sample to answer diagnostic process. In fact, in many ways, it is superior to PCR. It is faster and extremely sensitive, capable of amplifying single copies of the target in a fairly simple reaction setup. The drawback, however, is the relatively complicated assay design and the relatively complicated primer design, and some problems associated with cross-contamination, as a lot of product is being produced in these reactions. As a brief overview, without going into too much detail of the LAMP reaction, you can see here the schematic on the right, where instead of the usual 2 primers, as is common in PCR, you need at least 4 to 6 primers to do the LAMP reaction. The reaction proceeds by creating these looping structures, which is achieved by the specific primer design to generate these structures. This is coupled with a polymerase, a specific polymerase that has a strong strand displacement activity that will then amplify this fragment at a constant temperature, resulting in exponential amplification of the target, yielding concatenameric and somewhat random amplicons instead of the discrete products seen in PCR. And as already mentioned, this is all happening at a constant temperature. The enzyme is going around on this product and producing more of these products without the need of cycling of the temperatures up and down. However, there are some specific requirements to the polymerase to enable the LAMP reaction, as I already mentioned. And we have been working hard at SolisFAST developing a solution that fits all the requirements needed in this growing point-of-care market. The new SoliSD isothermal polymerase is at the heart of all of this. This new product comes in a flexible kit format, where it has all the components required to make sure that the LAMP reaction is a success. And of course, it's available in Lyo-compatible formats as well. and also a format that enables direct amplification from an RNA target called the RT-LAMP kit. So what are some of the interesting features of SoliSD, the product and the enzyme as well? If you're not using lyophilization, the stability tag incorporated in the enzyme reaction allows you to conveniently set up your reaction at room temperature, or when there is a need for lyophilization, the stability tag can help ensure the robustness required for the enzyme to help it tolerate the somewhat harsh lyophilization process. Another feature in the LAMP kit is what we are very proud of, is the unique SoliSD supplement that blocks the enzyme activity until the reaction temperature is reached, eliminating unspecific amplification and allowing room temperature setup, as demonstrated on the graph here on the right. This is great as the supplement enables the user to really get the maximum out of their assays by increasing reliability, decreasing variability, and allowing room temperature setup that can be very beneficial in more near patient or remote settings. In addition to this, we have worked hard to engineer and optimize the enzymatic properties as well. The SoliSD enzyme is really fast and has sensitivity down to single copies of the target template. It also shows great tolerance to common inhibitors and shows exceptional strand displacement activity that is critical for isothermal polymerases. It's available in glycerol-containing and glycerol-free formats, as I already mentioned, as well as Lyo-compatible RT-LAMP format for RNA targets. So if you're feeling like you're brave enough to try your hand at designing a LAMP assay, make sure to try out our flexible SoliSD kit. So I talked a bit about point-of-care testing. However, there are some challenges that arise in point-of-care testing, especially when working with RNA targets, as is the case for many viruses that we want to test for. As diagnostics moves closer to the patient and away from diagnostic labs, you can't always guarantee the same level of cleanliness. Similarly, you might want to use the sample directly without any purification steps. So one of the issues faced when working with RNA samples in those situations are the omnipresent ribonucleases or RNases. They're found almost everywhere, in every organism as well, as they are secreted by cells as a first defense against the various RNA viruses that exist. So these ribonucleases, they work by degrading RNA molecules into small pieces, and this is also what will happen to RNA samples in a diagnostic setting when these RNases are present or happen to be present in the sample. So in addition to being present and sticking to surfaces everywhere, another challenge is that they are very difficult to get rid of. They're one of the more stable proteins and can tolerate, for example, temperatures of up to 100 degrees, and often will refold back into the correct shape, making it very difficult to completely remove them from surfaces and also from just avoiding them happening to be in a reaction mixture at some point. Chemical methods exist to break them down. However, this is usually not possible in a diagnostic setting. So one option we do have in a diagnostic setting are ribonuclease inhibitors, proteins that can bind very tightly to the enzyme, these RNases, and inhibit them. The affinity of RNase inhibitors to ribonucleases is among the highest of any protein-protein interaction, and they are commonly used in many applications where preserving RNA is important, particularly in RNA-related molecular diagnostics. This is very common, and in the lab, in many situations during cDNA synthesis that happens constantly, or RT-qPCR reactions, but also other applications where RNA integrity is of critical importance, such as RNA sequencing or RNA or in vitro RNA synthesis, as is becoming more and more popular, with the example of mRNA vaccines that are produced in vitro becoming more popular as well, and finding many new applications for their use. Luckily, at SolisBiodyne, we have a perfect solution to help protect your precious RNA samples. SolisBiodyne's in silico designed ribonuclease inhibitor RiboGrip offers specific and strong inhibition of the most commonly encountered RNases. As with all other enzymes and proteins in our portfolio, it also has enhanced stability to temperatures due to the stability tag technology and can tolerate up to 60-degree temperatures for up to an hour if the assay or experiment requires it. Another feature that can be very beneficial is the unique high concentration formulation. It offers increased flexibility in assay design and gives the maximum control to the user if there is a need to specifically control the buffer composition, as might be the case with some newer platforms where the readout or the detection might be very sensitive to different components of the mixture. It's available in a glycer-containing in a glycer-containing buffer, in a glycer-containing format, or a glycerol-free version that is compatible with lyophilization, and with many great features to support it, as already mentioned. And we've had some great feedback concerning the performance of RiboGrip. It strongly inhibits RNase A, as can be seen here on the image on the right. Even at low quantities of RNase A, the RNA in this one-step RT-PCR reaction that we have done is fully degraded. Whereas when RiboGrip is included in the reaction, these on the left here, you can perform reactions even when significant amounts of ribonuclease are present in the reaction mixture. For example, one of our partners was struggling to get an RNA assay working in a particularly complex lysis buffer. However, the addition of RiboGrip immediately improved the results and sensitivity, really highlighting that when working with RNA, ribonucleases can be a big problem. So feel free to try it out if you're struggling in your RNA work. This might be the solution to help you improve your results, possibly. And now, as a small teaser, here's, in addition to our catalog Lyo-compatible products that we've talked about today, here's a brief look of what might be available behind the scenes in our custom solutions portfolio. For example, the highly concentrated SoliScript reverse transcriptase, and also the uracil DNA glycosylase, or UNG, as it's commonly called, that have also gotten great feedback. So we encourage you to reach out if you have any special requests in mind, and maybe we can work something out. And that's all from me. Thank you for listening. It was great talking to you today. Hope you found some of the information interesting. And if you have any requests or questions, feel free to reach out. And now I'm handing it back over to you, Hanna.
Thank you, Oliver, for this interesting talk about our isothermal solutions and also how to protect RNA samples. Very insightful and interesting. So now actually we have reached the end of today's webinar. And to sum up, we are really proud here that SolisBiodyne has now opened up a whole new product category, which is products for lyophilization. And here we have different products available. One of them for qPCR applications that is ready to be lyophilized, the SolisFAST Lyo-Ready qPCR kit with UNG. And we also have other Lyo-compatible kits and standalone components available, such as our RiboGrip RNase inhibitor, and also our brand new SoliSD BSM DNA polymerase for isothermal amplification. And of course, if you have any other interests for other products that you don't really find in our public product catalog, then still feel free to contact us, and we might have something waiting for you in our custom solutions catalog, such as a really highly concentrated reverse transcriptase or also a glycerol-free UNG enzyme. So it's a good place to also remind you where to contact us. We encourage you to go to our website to find more information about our products and to contact us via our information email. We also have a website chat available, and we also offer free samples. So if you are already interested to try something out, then we would be very happy to get your requests and to send you some free samples for testing. And now is also the place to submit your last questions to our webinar chat. And now when you do that, I will also cover one question about our lyophilization capabilities. And the question is about whether we can also offer lyophilization service or lyophilized products. And the answer is that we do lyophilization in-house for R&D and quality control purposes. But for industrial scale, we can work together with different service providers and third parties in that sense. So if you have a concrete interest to also get lyophilized solutions, then we also encourage you to reach out and we can talk and see what kind of a solution would be the best to offer you what you really need. So if there are any other questions, then we are also happy to answer you via emails. You can contact us, or if something was left unanswered in the chat, then we can also contact you after the webinar. But right now is the place where I thank you for attending. It was really nice to see you here, and we were really happy to introduce our new solutions. And hopefully we will hear from you soon. And right now, I wish you a nice day, a good evening, and thanks again from me and also from Oliver. And we wish you all the best. Thank you.
Thank you.